My name is Nestenius, and I've been programming since I was 10, 11 years old. One of my biggest achievements in the past, I created a community for developers online called Programmer 7 in 1996. Maybe some of you recognize that old site. So in 2000, I could actually live on this website, so it was my full-time job for 8 years, running this website, and I had quite a lot of traffic. And I sold it in around 2008, just in time before Stack Overflow came into the picture and killed all the independent developer sites. So it was a big fun project. I also been the co-founder of Edgement. It's a training and consulting company in Sweden with about 45 employees at most. I also spent time on Stack Overflow trying to answer questions and helping people in various topics like identity space, OpenID-connect, and .NET. I also in the past, in my young days, tried to make games for Atari ST computer. I was into the demo scene, trying to make demos and competing on the Atari ST. I even tried to build games for the Atari, for the Sega Mega Drive. So I wanted to make games for my Mega Drive, but I didn't have any equipment. So why not build my own equipment? So I reverse engineered the Mega Drive, built my own hardware developer kit, so I could program the Mega Drive and make small games running on it 30 years ago. And I also me and a friend made a music application for the Atari ST computer, a sound tracker that we sold through a publisher in France for 30 years ago, back way then. So I've done a lot of things, and today I'm a freelance consultant, a trainer, and I've done some training with Lund&Bendsen before, and my focus is on the .NET, C#, security, architecture, domain-driven design, CQS, and also OpenID-connect. And if you want to connect with me, I have a blog and a website, and also feel free to connect on LinkedIn. Important, do feel free to interrupt me with questions. The more questions, the better. And so let's get started with the first part. So the first part is to talk about cross-site scripting. And cross-site scripting is one of the biggest problems in security on the web. And if you look at various kind of top lists and there's one kind of report from HackerOne. The number one kind of vulnerability found on the web today is cross-site scripting. And HackerOne, that I kind of got this kind of list from, what they do is they manage different security programs for companies so that it's kind of, they actually pay people to report bugs to them. So if you report a nice bug to them, they will give you out money. And on their kind of, payouts, the cross-site scripting attacks and vulnerabilities is the main one. So it's a big problem today, and it's also a really complicated problem as well to do right. So then the question is, okay, let's see an attack in action. So if you want to try, it's safe, trust me, I'm a trainer, professional, So if anyone wanted to go to that link, and so feel free to go into that one, and you should go enter some e-commerce website and click on the button to the right, and they can just fill out your form. Don't enter your real credit card details. That would be a bad idea. But if I were to go into that page, you would see this page, and if I click on the right button here, I can fill out my name and my order, my credit card and my my email address and so on. And that's great. I place my order, everything is fine. I feel secure and happy. But at the same time, if I were to look at the kind of what happens in the background, so I can run a tool like, for example, Fiddler. So Fiddler is a web proxy that can show me all the traffic that is can send from my computer out to the internet. And we see that, if I zoom in here, I see quite a lot of traffic to some kind of hook.js all the time. So apparently this butcher page is talking to someone. So it's talking to my command and control server. So if I go to that server and I actually log in here, I can see that I have a number of devices, connected. And if I'm lucky, I can actually look at the log of those pages. Let's see if we can find something. So here you see my entry, drawer here, my where I clicked and what I typed. So basically, there's a key logger on this butcher page, sending all the clicks and key presses to my control server. So I can steal your information without you noticing. And I can do even more fun things. So for that machine, I can send commands to it. So to this, as long as this page is up and running, you see I can send quite a lot of different commands to it. Maybe I can do a redirect. So I can do a redirect to some other page. So if I kind of put this one, the beef one here, I just kind of put them side by side like that. I can redirect my browser to some other page. So in this case, let's see, I can, it's a bit small window here, but let's say I redirect to some page like, bing.com for some reason, just to be fun, bing.com. So I send the command, and now if things should work, the page on the left is redirected to Bing, because I can remotely control that browser page from my control server. That's pretty neat. If I go back to the page and look at the kind of core problem, the problem is, if I look at the web source code here, the problem is that somehow the hacker, or me in this case, managed to get my kind of evil JavaScript into the page. And that's all it takes, and then it's game over. Okay, so let's go back to the presentation and talk about the problem and what it is. So what is the problem here? So we all know that the browser downloads an HTML page from a server and renders it in the browser. Now, that's how the web works, and that's all well. And the main problem is that the browser trusts anything that it receives. So whatever the server sends to the browser will trust it and execute it or render it in some different ways. And the problem here now is that somehow, let's say the hacker managed to inject his evil JavaScript into the page. We see this script tag here. Then I'm hacked, and he can manage basically, if he's lucky, manage to steal all my cookies, my key presses, password, credit card, or secrets, or the content of a page, or do other bad things. Okay, so that's clearly not so good. And how? This is clearly a bad. This is implemented in a bad way. So if we were to implement this in a good way, in a secure way, the result should have been that all the content from the hacker should have been encoded and made safe. It should have been made to be treated as content. Because in the previous case, whatever the kind of hacker injects into a page, in this case, is sent along with all the rest of the tags on the page. And the browser can't tell the difference between the hacker's script tag here and all the other tags on the page. It's a tag as a tag. So the problem is that we often forget or don't do it properly to do this kind of encoding to make sure that the content from users or hackers can't be executed. That will be kind of the thing that they often makes mistakes in or forget to do properly. Make sense? Great. So and then of course the question is, how can the hacker get his bad script into the page? And there are several different ways of doing it, but we have 4 main categories that I will kind of talk about. And the first one is reflected cross-site scripting. So we have a victim here, we have a backend. So the hacker somehow has found a vulnerability on the server. He sends his victim a specially crafted link, and the victim clicks on that link. Maybe that request to the backend includes his cookies because maybe he's logged in, and because of the vulnerability on the backend, you get back the normal response, but it also includes the evil script from the hacker, and the browser will kind of download all the HTML and see what there's a script tag, let's execute it, and then the victim is hacked. And in this case, it's only the victim that is the target here. Only the one who clicks on this special link will be hacked. And the data, so the attack can be injected, as shown in the top here, through the query string in the link, but it can also be through the body of the request or the request headers. So there's many ways where the hacker can inject his bad script into the link or into the request, and then it kind of is reflected back to the victim and then executed in the victim's browser. Make sense? Any questions so far? Make sense? Good. So this one is only only the one who clicks on this vulnerable link is affected. Everybody else is safe. But then we have the more kind of serious one, and that is stored cross-site scripting. And in this case, the hacker submits maybe a product review, and in his review he includes his evil script. So it's stored on the back end, and eventually maybe so maybe someone has to kind of approve the reviews. So the employees or customer service that maybe looks at the reviews, or maybe the visitors to the page that they also kind of read the reviews, they will be kind of vulnerable to this attack, because then when they see this page, then this script will be executed. So you post something to your system, into the database, and later on when somebody views it, then they are hacked. Maybe it's a blog, maybe it's a product review, maybe it's like a comment, or it's a forum, or just part of an order. And the dangerous thing here is that a hacker might post his evil script as part of some data to maybe to the producer, and then they integrate with the partners, and then it's passed on to other servers. So data can travel quite far away, between different systems, and this makes it really hard. So when you make integrations and you receive data from other partners or customers or providers, you can't really trust that data, because that data might include some evil JavaScript or HTML that then later on, when you kind of view the data, you might have a page that is not kind of properly secured, and then you are hacked. So there's quite a distance between the hackers doing his thing and the victims actually looking at the data. And the thing is that there's even a book with a title that contained, so inside the title, it actually contained a cross-site scripting attack that actually was triggered by some book e-commerce companies. It's really, quite a clever way to prove your point. So it's, data can travel quite far, and today we do all kinds of integrations. So we receive data from all partners or providers, and can you really trust the data? So you really need to kind of make sure that when you publish data to the browser, you always encode it in a proper way. There's also one attack called DOM XSS, and DOM XSS is all about where you try to attack the JavaScript on a page directly. So maybe you have some JavaScript that reads from the query string and then in a bad way directly injects it into the DOM, and then you could in theory kind of then execute JavaScript. And there was quite a nice attack made again. They found a DOM-based, we found actually a DOM-based cross-site scripting vulnerability at Facebook, and this researcher got like $20,000 just for discovering that vulnerability. So it is really a big problem today, and so DOM-based cross-site scripting is one way where you can through a query string or inject things into the JavaScript and then execute it directly into the browser. But the main question is why is cross-site scripting so hard? And the problem is that the web is really complicated. We have a lot of different standards. We have HTML, CSS, JavaScript. We have URLs. We have XML, JSON, SVG, Math, ML. And we can also, as I show here on picture here, nest them inside each other. You can place JavaScript inside HTML and nest them. And really the biggest problem is that each of those standards have their own kind of rules for what's a quote, what's a safe characters, how do you escape strings, how do you make comments, and that really makes it really hard, because you really need to know the target for when you do encoding. So when you want to kind of display something to the user on a web page, you need to encode it always. And sometimes many of the frameworks do it for us, like Spring Boot or ASP.NET Core MVC or similar. Most of them do it for you, but you really need to do the encoding to be context aware. You really need to encode it correct to the right context. So, for example, if you're in .NET, you want to encode a given string. You have many options to do that encoding, and depending on which encoder you use and for the different target you have, you will get different results. So depending on the context, you really need to encode it correctly, because otherwise you will introduce new vulnerabilities. So that kind of shows the kind of difference in the output when you do encoding and try to make something safe, given a bad input like this one. So that's a really tricky question. So you can't just do one type of encoding everywhere. You really need to encode it depending on the context. This is a link or query string, or is it inside a JavaScript string, or inside an HTML attribute tag. There's all kind of different rules for different context. That makes it really problematic. And today we also have all those kind of that allows you to do like a Word or Google Docs in your browser. You can actually write HTML inside your browser and post it to your backend. Maybe you have a blog like a WordPress. You can compose your blog post in HTML in the browser, upload it. And to make that secure, you must always sanitize and to clean that HTML before you display it to the user, because otherwise you as a hacker could inject some bad JavaScript into the page, and then you would hack all the readers of your blog post. And to do that, there are many frameworks to do this sanitation. And the problem is that many of those sanitation libraries that do exist are either kind of pretty out of date or not really secure. And one of them that is kind of, I think is the most secure one, is called DOM Purify. It's for JavaScript and Node.js. And if I were to kind of run a demo on this one, let's see if I had here, DOM Purify. So there's a demo here, but if I were to kind of do a just on I just do something that would contain some bad script. If I were to sanitize it, you see that it removes this kind of dangerous part, the error part, and just gives me back the safe part. And the same if I were to do like a script alert says, it would also remove that part entirely. So only the image source 1 gets through this sanitation. So when you want to kind of display HTML-based content to the user, you always need to sanitize it to make sure it's clean and does not contain any, dangerous attributes or scripts or similar things. And DOM Purify is, I think, the one that is the most kind of, the best one to do that job today. So that's, one of the problem. There's a fourth category of attacks called, it's maybe not a cross-site scripting attack, but it's still pretty bad. So many times especially kids, they want to hack your friend's Facebook account. So you Google or hack friend's Google account, and you find a solution, go into the browser console, and then you press, and then copy some, JavaScript and paste it into the browser, and then your friend is hacked. But the problem is that you actually get hacked yourself. And today, so if you were to go to Facebook, and you go to the console, you actually find a message in the browser console just saying, stop, don't paste anything here that someone tells you to paste, It's really a bad idea, and it's a typical fraud thing. So it's really, I mean, a lot of the problem today is social, you click on some link, or you just think that, it's safe to copy something in here, but that's really a big problem. So self-XSS is really a problem today, trying to hack your account or expose you to bad things. So that's really a big problem, and which that's bad. So how can you kind of, if you, I want to, as a developer, want to try to do a good job with my encoding. I want to do it properly, but if I want to, can I do something to test it? So one way to do that is, so basically in your database, for each, column in your database, insert some HTML tag, and eventually, if you didn't do proper encoding, that one would then, basically make a request to a given endpoint. And if you have like a special endpoint like /XSS, then you could have some alerts that would be notify you that, someone made a request to this link. It shouldn't happen. So that's one way, introduce some, add some, HTML to a test user, and as part of your testing, you see if does this kind of script or this image source tag actually execute on one of our pages, and if so, you will be notified that that is the case. So that's one way of testing your system. But how can we then, protect us against or try to do a better job? Well, there's something called content security policy that can help you fight cross-site scripting vulnerabilities. So we all know that the browser, it downloads HTML, and that one will then in turn download other things like, styles, JavaScript, images, and that's fine. That's how the web works. But the problem is that if my page is hacked, oh no, damn it, it's hacked. The hacker injects some bad tags into the page, and now my browser will go out to the internet and go to the kind of evil domain here and download evil stuff. That's not good, So, and I mean, of course, we all try to make it as secure as possible, but eventually the hacker made it through his evil script, got into a page, and now what? Can we do something to protect us? And yes, we can. So we can add a content security policy to our website. So by adding a content security policy, we can actually block requests to unknown domains. Oh, that's good. So how does this work and how do you set it? Well, the policy is usually set as part of your response header. So when you make a GET request to get a page, you in the response header include a content security policy that gives instruction to the browser what you can do, what the domains can you go to, and to restrict access to unknown domains. And by doing that, then request to evil.now, for example, will be blocked. Okay, that's great. So what does the policy look like then in more detail? So the policy, as I said, is part of a response header. So as you see here, it's a response header here with all kind of various things. And the policy is just one of those headers. And it needs to be included on every page that you send to the browser. So that's all it takes. It's just a header in the response. Okay, you can also set it as a HTML meta tag in the page header, but usually putting it in the response header like this one here, it's much better and have more features available to you. But you can set it in HTML as well. Okay, so what does it look like? Well, if you look at GitHub's policy, so that is one line, that is one header in the response from GitHub. So it looks like that. And just to kind of show you how to find it. So if I were to go to github.com and I go to Fiddler and look at all my requests, I look for one request to GitHub, here perhaps. I can see the raw response here. I can zoom in here. That is my response from GitHub. And we see that there should be a one content security policy header here. And if I were to copy that specific header, let's copy that one, and we can just paste it into a Word document perhaps, just to see the kind of extent of it. We see that that's the policy. It says one line, pretty big one, but it's still, that's a policy. Okay, but this policy, just looking at this one, doesn't tell us that much. How can we make sense of that? Well, it's one line, but there's actually a structure in this document. So if you apply some structure to this content, you can actually see some patterns here. So in this policy, we have a set of directives and values for each directive. So the first one says default source none. That means that basically block everything, no request to outside, block inline JavaScript and styles, block everything. And then we say, for example, that fonts, if you want to load a font to a browser, you can only do that from GitHub, gitabassets.com. If you want to make a form post, it can only be done to self, where I came from, or to github.com, gist.github.com, and so on. If I want to include images in the page, I can only do that from the page I came from, or GitHub assets or identicons, github.com. And for example, scripts, JavaScript can only be downloaded from this link. And styles, the same thing. So I can whitelist what is allowed for the browsers to do. I mean, where can the browsers go and fetch different things? Images, script, styling. I can lock it down. So that's pretty powerful. So the CSP policy thing, was kind of started as an idea in around 2004, and the first came into the browsers around 2011, and then it has iterated a few times, and now we're up to what they call level 3 as a policy. And if we look at, so there's a site called Can I Use? So let's not that one. So there's a website called Can I Use? So Can I Use allows me to see for a given browser feature if it supports, and which browsers do support a given browser feature, when was it introduced, and details. And we see that most browsers today support the different kind of content security policy features. And this is a really good site, so when you want to kind of take a dependency on a new browser feature, you can see here what the adoption is, how many browsers supports it. And if I look at one of the more latest features, like CSS font palette that is coming, we see that there's only kind of Safari and that supports it, and nobody else. And it was going to be introduced in a given version, and about 1% of the browsers supports it today. So maybe it's not a good time to start adopting this feature, the CSS font palette. But other things you can find, and that's a pretty kind of useful site to see what can I use or not use. So that's good. Okay, that's good. So the directives, so I'm not going to go through all the directives, that's kind of pretty boring, but there's directives for most of the kind of important tags regarding security and content in your browser. So you can control images, font, styling, JavaScript, workers, objects, videos, and other things. And there's also some more special directives to control kind of using of iframes or sandboxing, and upgrading insecure requests, and so on. And for each directive, you can add one or several values to it to describe what's allowed and not allowed, for example. So you can control that maybe something is not allowed at all, or just from a domain it came from, or maybe I allow everything. So that's all depends. So if you want to kind of start creating your first policy, you can actually give it a try here. So so I have a page here. It kind of shows the kind of current time, and I have a calculator that prints 11, and I have 2 images. And if I were to look at the page source, it should not be any kind of difficult. There's one script here that shows the current time, and I have some eval that evaluates 5 plus 6 to calculate, and I have 2 images from 2 different sources. And right now I don't have any policies, so the page works fine. The script here is working, and the eval is working, and I see the 2 pictures. If I were to maybe set a policy, so I can, default, as I see, none. So if I set that policy, we see that nothing is working. The images does not work, the calculator or time is not shown. And in the browser console, I now get warnings that, it refused to execute the inline JavaScript, and it refused to load the images because it violated my policy from where I am allowed to download or access resources. So that's pretty good, because now, okay, it's pretty useless because the page, my JavaScript does not work and no images, so it's pretty useless, but it's a starting point at least. And I can, for example, then have an image source to maybe, okay, I accept images from upload.wikimedia.org. So if I add that one, it's going to semicolon like that. I use this policy now instead. We see that this image works. Okay, that's good. I can, okay, the JavaScript one, so the script source, I need to because this JavaScript I have now that shows the time here, it's inline, it's inside the HTML. And because of that, I need to be explicit and really allow that thing to occur. So I have to be doing unsafe in line. Then the time starts to appear. But at the same time, the calculator does not work because that one is using the infamous eval function. And that one is pretty dangerous because it can basically execute code and be really, really bad. So that one you also have to be very explicit, enable directly. So I have to add unsafe eval if I want to support the eval function. And now unsafe eval should be unsafe. Okay, so sorry. And now the eval works here too. So you see this, but I can block things, and I can whitelist from where I allow things to be downloaded from, and who I can access and control.
So in the image source, you have the option to have data. Do we have the data in script source as well?
What do you mean with data?
Pardon?
What do you mean with script data in the script source?
So in the image source, you can have data being base 24 encoded.
Yes, you can have a data colon, yes.
Yeah, can you have the same in the script source?
Yes, you can.
But it's hard to sanitize, isn't it?
Yes, of course. But data, okay, so data colon, what we're talking about is the feature where you can where you basically can embed, binary code. So this image that we see here, this logo here, is not a normal image. It's actually embedded into the page as a data colon schema. And you can do that also with JavaScript. And we saw that on the GitHub example, because that one actually had, here, image source data colon. And that is one reason to why you would embed an image or icon into the HTML body, like we see here, is basically maybe today a bit out of, not so modern way, but it's a way to reduce the number of requests made to the backend, because requests made to the backend using HTTP1 is expensive. So if you want to minimize the number of round trips to the backend, and you have a lot of small icons, you can actually embed them into the HTML instead to improve the page loading speed. More questions?
I find it interesting that you start out by saying everything is forbidden.
Yeah.
Then you switch on more and more stuff.
Yes.
So my prediction is that when you have a very advanced website, then you have switched everything on. So this is like you say everything is forbidden, and then you permit everything afterwards.
Yeah.
And also, I don't think this thing about whitelisting websites is easy to use, because when I write code, I write so that you can deploy it on dev 1, 2, and 3 and test and
Sure.
everything. So
Sure.
my web pages are deployed in a lot of environments, even environments I don't know about.
Sure.
So it's quite hard to use. Every time you use a website here, it's probably not going to work in all situations.
Okay.
For instance, if people take your web page and save it on a local disk and then try to show it, then suddenly it can't be shown because they like to take snippets of.
Yeah, okay. So there's many questions here. So first of all, this works on any domain you deploy it to, because you can use the self here, and that means where I came from. Where's the origin I came from? So even if you have deployed to test 1, 2, 3, 4, 5, you can use self to represent where I came from. But usually you have your static assets things, you have a CDN, or you have a special, so for all the images, or so you can always use the self thing to so you don't need to list all the sites you deploy to. It's only where you kind of want to download external resources from. The second thing about saving to HTML to disk, when you do saving to disk, you always forget about all the headers. And if there's no header, there's no content security policy. So I don't think it will kind of break if you were to download it and save it offline. It's only for the things that you during the download of that specific page. But then if you save it further on, it should not kind of break, I would think.
Yeah, I understand this, and of course you need to use those features when you build it. But also here, if you take some of these sites, they are publicly available, so you can publish stuff on GitHub and add your evil code.
Yes,
yes,
of course. Of course.
You are protecting for some
yes.
stuff, but it's still open in other ways.
Yes. So I mean, there's many, there kind of many kind of. It always it depends, but one it's a good question. So if I go back to my I have some demo pages here. So if I were to look at, for example, I just can kind of need to find CDN. You can always go to, you can, for example, include like the jQuery from and use the jQuery hosted at Google CDN. And many libraries are hosted by Google, and you can simply refer to them like this. And this is a good way because they are hosted in the Google Cloud, it's close to every user, it's fast and reliable, and all that's great. But and yes, if you now whitelist this, developers google.com or this kind of the domain here, then all the scripts hosted on this domain will be, available to the hacker to download. And okay, but the really big problem here is that this site hosts also all the old version of jQuery, and old version of jQuery have, sometimes had security bugs. So if you, whitelist this CDN and the hacker refer to some old version of jQuery or one of the, other frameworks here, he might get into your site and execute, his evil scripts. So there's also a trade-off of, how much you try trust the backend? But it's a good question. So anyway, so in my example here, we saw that I can control the page access, and the page will, complain in the console when the page is trying to do something that breaks my policy. Make sense? Good. So, and to create your first policy, you can always, like I did in my example here, use default source none, and that basically says none for all the different directives, block everything. But to get a more kind of sensible one, maybe you should use a default source none and set a few of them to self. That allows you to contact the server you came from to download scripts and images. That's a pretty kind of a good kind of starting point. And then you can add more and more domains as you like. But okay, you introduce your first policy, and then you deploy it, and take a break, you go on vacation. But then your users might start complaining, because me on the back end does not maybe always know if I have a mistake in my policy, and my users are seeing broken images or broken features. I'm not aware of how the end users experience my site. So built into the CSP system is a reporting feature, so you can actually add a report URI directive and instruct the browser to please phone home when something is breaking my policy. So basically, that allows you to send, tell the browser to please report, when something is breaking. And that's great. And that report then, includes pretty detailed, error description that then you can analyze and, take action on. And to demonstrate that, there's even a commercial and also free to use site that you can use to send all those browser reports to. And that's why they call it the report UI, and they do like 1 million of reports per second. They're pretty big nowadays. And so I can go into my account and see that, currently I don't have any reports here, or maybe one. It's a bit, okay, so it's today. Okay, so that's good. So basically, if I were to let's do like this. I can do clear Fiddler here, and I go back to my site, and now I make a request that is kind of violating my policy. And if I go into Fiddler and look at the traffic, I should see that the browser makes an extra request to report the URI with my kind of the violation, and eventually that one will. So the first request up here is my page load, and then the browser made, in this case, 2 requests to report URI with reports of broken things. And then eventually, after maybe 10 seconds or something similar, you should see more reports popping up here. It usually takes maybe half a minute or something before they show up here, and you can then get some statistics and graphs and reports on things that breaks in the browser. So that I think is it's a good thing to have. And there's coming more and more reporting features to the browser to report on other things as well. Other problems, browser crashes or other things. So you can get more and more insight in how the browser, behaves and so on. So that's good. Okay, so there's another thing called Nonce. So, if you look at the policy for Twitter, it's really, really ugly and big, And as I said, before, it can be pretty hard to maintain. and how can you really kind of trust that it is actually secure? That's a big problem. So what can you do instead? Well, if you look at the policy for Google Docs, google.com, it's a pretty small one. And if we expand it a little bit, we see that basically the base thing, or the most interesting thing, is the script source here. And it have this kind of nonce thing here as a kind of the central thing. Okay, so what does that mean? Well, it means that a nonce is a cryptographic, one-time, it's a random number basically. So what they do is on every page response back to the browser, they insert a random number. Okay, so it's for every request, every page load, you get a new number in this header. And then each script tag or style tag needs to have the same number as an attribute. And only those script tags that have a matching value will be executed in the browser. So if a hacker tries to inject his own script and he does not have that value, then that script will be blocked and not executed. So that's one approach to secure it. Sure, it's more work in the backend because you need to inject this nonce value everywhere, but it's doable. And so basically, to demonstrate this thing, I have a page for that. Let's see. So in this case, I have a page that does not kind of set that nonce, and we see that we get different arrows here because the script tags does not kind of contain that nonce tag. But in this case, the page works. So okay, so if I kind of go to Fiddler and I kind of load this page a bunch of times, we see here that if I click on these links, let's see the raw response here. It's kind of going to, we see the nonce value here. So this one is the UK3 in this case. If I go to someone else, some other response, or it's a different value. So each time this value is different, as you see, this nonce value. So I have the same value for both the style and the scripts. And that means that in my code here, I need to inject those nonce values, and we see it here and also up here. For the script source and the link tag to work, I need to have that part included. And if I reload the page, you see that value changes on every page load. So that is how Google Docs do it. So just to kind of summarize, when you talk about policies, I think it's a good practice to not try to have one policy for your entire site. Instead, try to have one for your maybe sensitive account part, and one for a product part, and one for a blog, and one for maybe homepage, so that you can, restrict each area independently. And also, there are different validators that you can use to validate your policy, because it's very easy to make mistakes. And one is from Google, and it allows you to evaluate your policy. So it's a sample unsafe policy, and it can check it for you and give you recommendations of things to add. Because, as we have used policies for quite some time now, we have kind of gained some experience and knowledge on best practice using policies. So do validate them. I think that's a really, really important thing to do. Yes? Yeah. So I think it's maybe a good time to wrap it up. And I think the final thing is that the content security policy is a defense in depth feature. It's not something that should be your kind of main security feature. You should always do everything else properly, but as a last defense. If your front end or back end web encoding does not work properly, or the hacker managed to get through, your CSP is kind of your last in defense for not including some weird Bitcoin mining script from Russia or China or whatever. So I think it has a place, and properly used can protect you against a few types of different attacks. So maybe a good time for questions. Yes?
In general, would you say it's possible to create a site with functionality and then add security, or is it almost a necessity to start with security?
I think you should always start with security from scratch, because retrofitting security or identity afterwards is usually pretty painful. But of course, security is always an ongoing battle, so you're never done with security. And I really think that security is important, that every developer have a basic fundamentals, because today, it's a war on the web today. Hackers, robots, spies, all the kind of robots walking around the web and trying to hack you and find, vulnerabilities. So I think every developer should have the basic fundamental understandings of what is the cross-site scripting, what is a SQL injection, because I really think it's irresponsible to let the developers develop web applications without knowing those basic, sanity things. It's like driving cars without a driver license. It's also not, appropriate. So really, I really think you need to have, a basic understanding of all the things that can go wrong, so you can do a better job, protecting your users, your data, your company, because it's easy, very, very easy to make mistakes, and then it's game over. And then, we want
to
to...
need a programmer license.
Yeah, almost.
Security license.
Yes. Any more questions? Yes, in the back.
So what about tooling support? Can you do some checks in CI/CD pipelines and so on, or do you have to wait until you have actually deployed?
CSP is a browser-only thing, so it's only kind of evaluated and executed in the browser. So it's not something you maybe would do in your pipeline. Sure, you could run through your page like a QA test to make sure and see if it reports something back to you. There's also one other interesting thing called Csp Report Only. There's also an option. So if you I want to do a policy, I want to roll it out, but if you roll it out, you will actually start maybe breaking users, and you don't want to do that. But there's one header called Report Only that you can deploy first with your policy, and it will not break anything. It just report and it can observe and report back to you if there are any problems, but it will not going to block anything. So it's a good starting point when you want to roll out a content security policy, just to kind of try it out to see what happens. Important to know is also that various browser plugins or bookmarklets might trigger policy violations, so you might get a lot of kind of spam reports back as well, or false reports. But in general, I think it's a good way to lock down your site and to create like a firewall inside your page, so you can't access the Russian Bitcoin mining scripts.
Så, tak for det, Tore.
Ja, tak.
Så det var det sidste spørgsmål.
Thanks.
Very nice.
Yeah, thanks.